All right, hope everybody is enjoying their Wednesday evening. I'm going to record a video of problem 2, part A. I'm going to let B, I'm going to leave that for you all to do, but I'm going to do 2A. This is on the homework that is due. Remember, we changed this due date to actually being Thursday, right? January the 15th, right? So again, I'm on problem 2A. And I'm going to just sort of walk through this. I'm in fact going to do all 4 steps with you here right now. So it says aspirin prevents blood from clotting and prevents strokes. The second European stroke prevention study asked whether adding another drug, dipyridamole, would be more effective for patients who already had a stroke. Here are the data on stroke and deaths during the 2 years of the study. So, and then question A is there evidence, significant evidence, that the addition of this drug will result in the decrease in the proportion of strokes. So we have a 2-sample, and let me get back to the record mode. We have a 2-sample proportion test, 2-sample Z proportion test. Make sure you put the Z there. 2 samples because we're comparing aspirin only versus aspirin plus, let me make sure I get the spelling right here, it's kind of a long word, dipyridamole. Dipyridamole. So there are 2 samples. And it's a proportion test because this is categorical data, right? And the other piece is categorical data given as a categorical data which is given as a percent. And in parentheses, I'm just going to write how I'm going to calculate it, which will be the number of strokes divided by total patients. Let me define the variable. So P1 equals the probability of getting a stroke for the aspirin group. Probability of stroke after taking aspirin. P2 is probability of a stroke after taking aspirin. And this other drug here, dipyridamole. So now we have to write our hypotheses. So our hypotheses are that P1 equals P2. Remember, the null is the one always with the equal sign, and the alternative is that P1, the probability of getting a stroke after taking aspirin only, we think that should be higher than the probability of a stroke after aspirin. And this is what we're testing, is the second probability less than the first? So that was the name the test step. Now we have to do the conditions. So sample 1, NP is greater than or equal to 10. So N on the first sample was, N was 1649, 1649, and P is 206 divided by 1649. So let me calculate that out. So this is really P1. So P1 equals, forgot the number here. P1 is 206. This is the number of successes. Success is really in quotes here because success means getting a stroke, divided by 1649. So P1 is 206 divided by 1649, 0.1249. So the question is that greater than or equal to 10? Well, 1649 times 0.124924 is 206, which is absolutely greater than 10. We have n times 1 minus p1. Is that greater than or equal to 10? Well, n, of course, 1649. 1 minus 0.1249 times 1649 equals 1443. Okay, we assume, does the problem say it's an independent sample? Let me take a look. So we assume it's a random sample. So assume random sample and independent. One patient getting stroke does not affect the other. One patient getting a stroke does not affect the other. And the other condition is that the population of people taking aspirin is 10 times the sample. So 1649 times 10, 16,490. That's sample 1. Now we do the same conditions for sample 2. First, let's find P2. So P2 is the probability of getting a stroke with sample 2. So 157 divided by 1650. divided by 1650, 0.095. Okay, so n times P2 is greater than or equal to 10. N is 1650 for the second sample. P2 is 0.0952, greater than or equal to 10. Let's see what we get. 157, greater than or equal to 10, so that's good. N 1 minus P2, greater than or equal to 10. So 1650, 1 minus 0.0952, greater than or equal to 10. 1 minus 0.0952 times 1650 is 1493. Absolutely greater than 10. Again, we assume random sample and that independent. Let me get a new pencil here, guys. It's a little bit dull. That next one I grabbed is dull. This is good. Independent. One patient doesn't affect the other. And population taking combined is 10 times the sample, 16,500 people. Combined drugs. Thus, since all conditions are met, both sampling proportion distributions are approximately normal. Both sampling proportional distributions are about, hands getting a little tired here, normal. Almost done though. Here comes the math. So we just did the conditions for both samples, now the math. So remember, Z equals P hat 1, or not, there's no hat here, remember, no real hat here, just P1 minus P2, all divided by what? Well, it's divided by square root of P1, 1 minus P1 over N1, plus P2, 1 minus P2 over N2. That equals P1. If we go back, we found P1 on the conditions already. P1 was 0.1249. P2, we found that earlier, 0.0952. So P1, 0.1249, 1 minus 0.1249 over N1, which was 1649, plus 0.0952, 1 minus 0.0952 over 1650. Let's see what that equals. So now we go to the calculator. So we go stat, we go test, and we want a 2 prop z-test. So X1, how many people were in X1? So how many successes in group 1? How many successes, 206 in group 1? So 206, N was 1649. How many successes in the next group? In the next group there were 157, P2, divided by 1650. We want to know the probability that group 1 is bigger than group 2. So the probability that group 1 is greater than group 2. Let's calculate. And here we are. We have a z-score of 2.73, 732. And let's draw this. .00315, alpha 0.05, and now we finish it up. We say, and by the way, I got the p-value from right here, and the z was right here. So now our conclusion is, since p-value of 0.00315 is less than 0.05, the significance level, let me get a new pencil, this one's about to break, I apologize, let me just go to the pen, forget it. Significance level, we reject the null, and we conclude that aspirin and dipridamole, let's go back to see what the question asks. That usually tells you what to write in the sentence. That there is significant evidence, or that you conclude that aspirin and dipridamole will result in the decrease in the proportion of strokes. Really, that adding disfrimidol will statistically significantly reduce the proportion of strokes. There we have it, and that is part A. So we started off with naming the test, then we went to the conditions, first for sample 1, then for sample 2, then we went to the math, and finally we ended with our conclusion. So there it is, folks. Thanks for